In this video, we're going to look at a couple of examples on factoring non-quadratics in quadratic form. So the first one we have is x to the fourth plus 3x cubed minus 18x squared. Remember, when you are trying to determine if something can be factored in quadratic form, the first thing you want to do is make sure you factor out a GCF. And then take a look at the polynomial left and see, can it be factored as a quadratic? Can it be changed to a quadratic form? So if we take a look, x to the fourth plus 3x cubed minus 18x squared, I see fourth power, third power, and second power of x. I actually see a GCF here. So what I'm going to do is I'm going to factor out that GCF, and that's going to give me x squared plus 3x minus 18. And we'll go ahead and look at our new trinomial. X squared plus 3x minus 18, it's a quadratic. So numbers that multiply to give me negative 18, add to give me 3, is positive 6 and negative 3. So my factored form is x squared times x plus 6 times x minus 3. Let's go ahead and solve this as well to get the three answers. First, we set x squared equals 0 and solve. Square root x equals 0. X plus 6 equals 0. You know x will be negative 6. X minus 3 equals 0. You know x would equal positive 3. And so these are my solutions. This is my factored form. So this one was very basic because it was a quadratic after I took out the GCF. I didn't have to look for the pattern for can it be factored as a quadratic even though it's not written in that form. But this one is a good example to practice identifying if a trinomial can be written in quadratic form and how to factor it from there. So we have x to the fourth minus 7x squared plus 12. There is no GCF in all three terms. So now I'm going to look at my exponents. I have a fourth power for the first one, and I have a second power for the middle one. So can this be written in quadratic form? Is the middle exponent half of the first exponent? And the answer is yes. So I know I can factor this in quadratic form. So now we're going to try. And to help yourself out, it might be good to write out what it would look like if it were quadratic using a different variable. So I'll use y. So it would be y squared minus 7y plus 12. How would I factor this? Numbers that multiply to give me 12, add to give me negative 7 are negative 4 and negative 3. So it's the same idea here. Remember, we saw the pattern is the first exponent is split in half. So that's how I'm going to factor the one over here. I'm going to take this fourth power and I'm going to split it in half to get x squared and x squared. We know it's minus 4 and it's minus 3. And so each one you go ahead and factor and solve. Now for this one, it's a difference of squares. So I can factor it as x plus 2, x minus 2. And for this one, it's not a difference of squares. 3 is not a perfect square, so I'm going to go ahead and leave it alone. To solve, remember, set each one equal to 0. So x plus 2 equals 0, x is negative 2. X minus 2 equals 0, x is positive 2. To do x squared minus 3 equals 0, you would add 3 and then square root both sides. And remember, you deal with a plus or minus when you're square rooting the equation. So my four answers are positive negative 2 or positive negative square root of 3 for x. So I hope you found this video helpful when it comes to factoring non-quadratics in quadratic form. Remember, look for a pattern first in your trinomial. Is the middle exponent half of the original? And then when you are factored in quadratic form, it would be helpful to write it as if it were a second power and factor it, because that helps you see what each factor will look like. And then you take your leading exponent, the degree of the trinomial, and you split it in half for each factor.